Okay. So now I'm going to go one step further. Can I get rid of those lines to get it all back on the screen? I'm going to say, for f in functions, print a call to f. Okay, I've got a for loop. First time through the for loop, hello is assigned to f, and then we call it, so it should print out hello, sweetie. Second time through the loop, goodbye is assigned to f, so we call it, it should print out come back soon. Okay. If I have two pieces of paper, I'm going to pick on the two of you. Okay? Your secret magic power is dancing. Your secret magic power is shouting. Okay? Sorry, I've got a 3-year-old. This is pretty much what 3-year-olds do on a Saturday afternoon. Okay? So, now that I've got these two verbs, I can just go through the list and say, do whatever it is you do, and do whatever it is you do. Okay? You would immediately start dancing if you were less inhibited, and you would immediately start shouting if you were less afraid of terrifying people in the room and having the security staff come up. Okay? Works so far? She's a verb and he's a verb. She knows how to do something, he knows how to do something. So I can just say, do whatever you do. Get the verb, call the verb, please do whatever it is you know how to do. Next one, please do whatever it is you know how to do. That's what this is doing. Okay? I get the first verb, the first function, out of that list, and I say, right, let's call it. This loop doesn't know what that function does. It just knows that it's in the list and I'm supposed to call it. Okay? It does something. It's a function. That's what a function does. It does stuff. It's a verb. So please go and do that. Come around the loop again, grab the next one. Please do that. Everybody okay so far? Okay. So if I've told you the truth, and yes, I have. Okay? That's my list of two functions. Remember, they're just pointing at instructions in memory. Come around the loop, get the first block of instructions, and the parentheses there say, okay, go do those now. All right? I actually want you to go and do the instructions that is pointing at. It's pointing at hello, so it gives us back hello, sweetie. Now, I want you to go and do whatever those instructions are. F is pointing at that. We call it. It says come back soon. Okay. Why would I do this? Well, okay. Suppose I have defined low pass of signal to mumble, mumble, return result. Def high pass of signal, mumble, mumble. I'm not going to actually return result. Def truncate signal, mumble, mumble, return result, and so forth. I've got a bunch of basic functions, each of which knows how to do one thing to a signal, and it returns the new signal. All right? It takes in, sampled values, and it returns the filtered result. If I say that whole thing is low pass, truncate, high pass, I can then say raw signal equals read signal from file of whatever my file name is, and then for function in whole thing, okay, whoops, signal is do that function on the signal. What do you think this is doing? Well, it's going to read the signal in from file, and then it's going to say, right, pass that into, what are we doing? We've got a loop. So the first time through the loop, function points at low pass. Okay? So do a low pass filter on that signal. Second time through the loop, function points at truncate. So now truncate the result of whatever we just did. Third time through, func points at high pass. So now do high pass on truncate of low pass. I realize from a signal processing point of view this doesn't make a lot of sense. Right? But you get the idea. What I can do is say, here are some primitive functions that each know how to do one operation. I don't have to write the code to apply them in particular orders. If I want to change up the order in which they're applied, I could, for example, just do that. I could truncate, then do low pass, then high pass. The loop, which is applying these functions one after another, doesn't change. I've got a list of functions, and I tell you, do these things in this order. Okay? You've all probably worked with code that does this. If you're working with something like Audacity and you're applying a chain of several filters, do this, then do this, then do this, then do this. This is what it's doing behind the scenes. It's got a bunch of functions, each of which is one kind of filter you can apply to a signal. And when you construct your pipeline and say, I want this one followed by this one followed by this one, it just puts them in a list. It has one function that knows how to do the loop, that knows how to take these things one at a time and apply them to the signal, which makes it really easy to add new ones. You can define, what's your favorite signal processing function that isn't already in this list? What else do you do to autofiles? Which?
FFT. FFT.
FFT. Okay, so you could define an FFT, right? And you could say, right, I just throw this into the list, and now it's being applied to the signal as well. I don't have to modify this piece of code. Okay. So let me show you an example, and it might make this clearer. Okay. Def high pass of signal is, result is the empty list. Okay. And for value in signal, if value greater than 100, result.append 100, else result.append of the value, return the result. Okay? Everybody see what this is doing? There's my input signal. Anything greater than 100 gets chopped down to 100. Okay? If you're less than 100, I just copy you into result. If you're greater than 100, I pull you down. Let's make that 10 rather than 100 to save me a bit of typing. Okay? Pretty silly function so far. Okay? Def low pass of signal is, for v in signal, if v is less than 5, result.append of 5, else result.append of the value, and return the result. And def shorten of signal is result equals that, I equals 1, while I less than len of signal minus 1, result.append signal at I plus equals 1, return result. So this is giving me everything except the first, giving me everything except the first and last values. Right? It's copying out of the middle. It's just throwing away the first and the last signal. Okay? So now I've got three things I can do to signals: high pass, low pass, and shorten. Okay? So let's start off with my data is 0, 1, 2, 5, 7, 9, 11, 6, 13. Okay? Bunch of numbers. Print high pass of data. Okay? Everything that was greater than 10 has been chopped down to 10. So the 11 and the 13 have turned into 10s. Right? So far, so good. Now, let's print low pass of high pass of data. Okay. Let me come back here. Show you what the original data is. Okay. So, original data is those numbers. High pass of that, we've chopped down the 11 and the 13. Low pass of high pass, we've raised the floor. Okay? Pretty good so far. And now, what do I call it? Shorten? Yeah. Print shorten of low pass of high pass of data. Whoop. What have I got wrong here? Missed a parenthesis, sorry. Okay. All right. That is the previous one with the first and last value thrown away. Hard to see because they don't line up, but that's that 5, that 5, that 5, the 7, the 9, the 10, the 6. Good so far? Okay. If I want to change the order in which the filters are applied, I've got to come in here and edit this line of code. Right? So let's look at another way to do this. I can say filters equals high pass, low pass, and shorten. Then for f in filters, data is f of data. All right? First time through the loop, f is high pass. So take the data, munge it, put it back in data. Second time through the loop, f is low pass. Take the data that just came out of the high pass, munge it, stick it back in data. Third time through the loop, and so forth. So if I'm right, this should produce the same answer. And it does. Okay? This is doing the same thing as that. Everybody okay so far? Here, I'm saying, and I think you can all read this, you've all survived at least one math class at some point. There's my data, run it through that, take the output of that, run it through that, take the output of that, run it through that, and that's what I finally print. Here, I'm saying take this, apply it to data, save the result back in data, and then apply this one, and then apply this one. Okay? If I want to change the order, I can just change the order in which they appear in the list, just as I would do that.